a very, you can notice this is in capital, a very special subgroup. This is subgroup generated by an element, and this is extremely special. This actually we have already seen. This we have already seen. Just think about it. If I give you, let me give you a group, let me give you Z comma plus, you know that this is a group. What is subgroup generated by 2? Let's see. What is subgroup generated by 2? What that means? First of all, what that means? Subgroup generated by 2. That means this is same as smallest subgroup that contains A. Smallest subgroup that contains A. That contains A. This is the definition. See, that contains A, means that contains 2. So subgroup generated by 2. This is your group, and I am asking subgroup generated by 2. What is the subgroup? What is the subgroup that is generated by 2? It means a subgroup, a smallest subgroup that contains 2. A smallest subgroup that contains 2. And this is the symbol we will use. This symbol means subgroup generated by 2. Okay? Yes or no? This symbol means subgroup generated by 2. So from where should I start? Anyone want to tell me from where should I start? Take identity element, because you are creating subgroup. So take identity element. Contains 2. So take 2. Contains 2. So take 2. करण आया है तो अर्जुन भी आएगा. You know that movie, Karan Arjun. करण आया है तो अर्जुन भी आएगा. So if 2 is there, so 2 plus 2 also will be there. So 2 plus 2 also will be there. Because 2 is there, so 2 plus 2 also will be there. करण आया है तो अर्जुन भी आएगा, right? So 2 plus 2 also will be there. And if these two are there, then 6 also will be there. Because you are creating subgroup. And if, okay, so finally 8 also will be there. From these two, 8 also will be there. 10 also will be there. 12 also will be there. Inverse of 2 will also be there. Inverse of 2 also will be there. Now, Karan आया है तो अर्जुन भी आएगा. Minus 2 he is here. So minus 2 square also will be here. Right? Yes or no? Karan आया है तो अर्जुन भी आएगा. You know. So minus 2 is here. So minus 4 also will be here. So minus 6 also will be here. So what is subgroup generated by 2? That is same as 2z. Yes or no? That is same as 2z. Means all the even numbers. This is the subgroup generated by 2. Okay, actually, what is subgroup generated by 2? This is like this. It is like this. Identity element. Identity element means 2 power 0. Identity element means 2 power 0. This is your subgroup generated by 2. This is your subgroup generated by 2. I can also write like this. I can also write. This means 2 power 0. This means 2 power 0. This means 2 power 1. This means 2 power 2. This means 2 power 3. This means 2 power 4. This means 2 power minus 1. This means 2 power minus 2. This means 2 power minus 3. So can I say subgroup generated by 2, that is 2 to the power n, where n is integer? Yes or no? Is this clear? So all the powers of 2, all the powers of 2, this is your subgroup generated by 2. All the powers of 2. Is this clear? Tell me. Let's take another example. For example, take this 1 iota minus 1 minus iota multiplication. Give the subgroup generated by iota. What is the subgroup generated by iota? Remember the definition. We want subgroup which is generated by iota. It simply means I am asking subgroup that contains iota. Subgroup that contains iota. So iota power 0 will be there, or identity element will be there, right? First of all, you take identity element. Take identity element. Okay, iota should be there because subgroup generated by iota, so iota should be there. Karan आया है तो अर्जुन भी आएगा. Iota square also will be there. Iota cube also will be there. Iota power 4 also will be there. Iota inverse also will be there. Iota power minus 2 also will be there. Can I say this will be infinite? Can I say this will be infinite? No, no, many of them are same. If you notice the subgroup generated by iota, that will be identity element, iota. Iota square is -1. Iota cube is minus iota. Nothing else. Everything else will repeat. Now everything else will repeat. You can notice this is minus iota. This is this is -1. Sorry, this is -1. This is minus iota. This is 1. This is minus iota. And what is this? This is -1. So this is the idea. So I can say the subgroup generated by by iota, that is G itself. Yes or no? That is your G itself. That is G itself. Correct or not? Subgroup generated by iota, that is G itself. What is subgroup generated by 1? That will be 1. It's only 1 because 1 power 0 will be there, 1 power 1 will be there, 1 power 2 will be there, 1 power -1 will be there, 1 power -2 will be there. Everything is 1. Everything is 1. This 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 is 1. Everything is 1. So subgroup generated by 1, that will be only 1. What is subgroup generated by -1? Subgroup generated by -1, that will be -1 power 0, -1 power 1, -1 power -1, -1 power 2, -1 power -2, and so on. So what is -1 power 0? That will be your identity element. What is -1 power 1? Okay. What is -1 inverse? -1 inverse, that is -1. -1 power 2. -1 power 2. That is 1. Minus power. Okay, so this will be 1 and so on. So if you notice, that will be 1 comma -1. This is the subgroup generated by 1. Anyone has any doubt in this? So let me tell you, this is the note. Okay, just understand, and this is extremely important. Let me tell you, this is not only important, this is extremely important. Many nice questions will be created on this in the quiz, in the homework, in the test series, in the GATE exam. Many nice questions are created on this concept, which this is a very cute concept. You know, subgroup generated by element, one element. So remember, if you have this G comma star, let's assume this is a group. Let A belonging to G. Okay, then what is this symbol? This symbol means subgroup generated by A. Remember, this symbol means subgroup generated by A. And what this means? Subgroup generated by A. What this means? This means the smallest subgroup that contains A. That means smallest subgroup that contains A. That contains A. And that is same as basically all the integer power of A. This means all the integer power of A. So this is the final definition. So subgroup generated by A, remember, this is nothing but all the integer powers of A. Take care about the integer power. Don't only take the positive power, all the integer power. So subgroup generated by A, that is set of all integer power of A. So this is, if you have element A, then subgroup generated by A. What is the subgroup generated by A? That will be this. All the integer power of A. All the integer power. So A power -1 is your inverse. All the integer power means this is your A inverse. A power -1, A power -2. So we got A inverse, right? All the integer power. So automatically inverse is coming. Automatically identity element is coming. because a power 0. This means your a power, this is your identity element. This is your identity element, remember. This 1 is not 1, this is your identity element. Okay, so note that. It can be, this is your identity element. So I can say this is your identity element. Let's change it. So this is the identity element, and this will be a power 0. So you can notice that all the integer power of a, that will create everything. It will create inverse, it will create identity element, it will create everything. Whatever you want, it will create. Now this nice observation you make, this group I gave you, can you notice that one thing? Tell me, what is the subgroup of 1? What is the subgroup generated by 1? That is 1. What is subgroup generated by -1? That is this. What is the subgroup generated by iota? What is the subgroup generated by iota? That is G itself. What is subgroup generated by minus iota? That is G itself. Can you notice that these two elements, they have power to generate G itself? Can you notice? 1 -1 cannot generate G itself. I can say that 1 comma -1 cannot generate G, cannot generate G, cannot generate G. But if you notice, iota comma minus iota can generate whole G, can generate whole G. Yes or no? These are interesting, right? Iota minus iota, they can generate whole G. So they are called generator of G. Because they can generate whole G, so you can notice that iota comma minus iota can generate whole G, can generate. So I can, for example, I can say iota can generate whole G, minus iota can generate whole G. I can say yes or no? Iota can generate whole G. You can also notice minus iota can generate whole G. So what can I say? Because they can generate whole G, so what can I say? Iota is a generator of G. Yes or no? Iota is generator of G. Very simple. Iota is a generator of G because it can generate whole G. So iota can generate whole G. So iota is generator of G. Similarly, minus iota can generate whole G. So minus iota is a generator of G. Okay, because minus iota can generate whole G, so minus iota is generator of G. So if I ask you how many generator of G are there, so for this G, how many generators are there? This is your G, 1 comma -1, iota minus iota. So what are the generators of G? That is iota comma minus iota. These are the generators of G. There are two generators of G. For G, we have two generators. This is a generator, this is a generator. They will generate G itself. Okay, so what is a generator? If I give you any group, so this is the definition of generator. What is a generator? For any group, if you have any group G, if you have any group G comma star, then G belonging to G is generator of, is a generator of G if and only if, what is the definition? Tell me what is the definition. You have a group G, G comma G is generator of G. It is generator of G, means it can generate G. Then what can I say? I can say G is itself, G is equal to subgroup generated by G. It means G is equal to subgroup generated by G. Yes or no? G is equal to subgroup generated by G. Subgroup generated by G means G can generate everything. So this G itself is equal to subgroup generated by G. This is the definition of generator. What is the generator in this? If I give you this group Z comma plus, what are the generators? What are the generators in this? In this group, what are the generators? Yes, 1 is the generator. Yes, very good. Because what is the subgroup generated by 1? Subgroup generated by 1, that will be 1 power 0, 1 power 1, 1 power 2, 1 power 3. Subgroup generated by 1, 1 inverse, 1 power minus 2, and so on. So subgroup generated by 1, what is this? 1 power 0 is identity element. 1 power 1 is 1, 1 power 2 is 2, 1 power 3 is 3, 1 power minus 1 is minus 1, minus 2, minus 3. Can you notice that one can generate the whole? So I can say, so what are the generators? 1 comma minus 1. 1 is also generator, minus 1 is also generator. You can notice that subgroup generated by 1. See, this is the subgroup generated by 1. Subgroup generated by 1 means 1 power 0, 1 power 1, 1 power 2, 1 power 3, 1 power 10, 1 power minus 1, 1 power minus 2, integer power of 1. You can notice that this is the subgroup generated by 1, and this is equal to G. See, this is equal to Z. So I can say that subgroup generated by 1, this is equal to Z itself. Similarly, subgroup generated by 1 also will be same as subgroup generated by minus 1. That also will be same as Z. Is it clear? Okay, and what is the subgroup generated by 2? What is the subgroup generated by 2? 2 power 0, 2 power 1, 2 power 2, 2 power minus 1, 2 power minus 2. So what is that? This will be your identity element. This will be 2, this will be 4, this will be 6, 8, and so on. Minus 2, minus 4, minus 6, and so on. So you can notice that subgroup generated by 2, that is equal to 2Z. That is equal to 2Z. And this is not equal to Z. So this 2 is not generator. So this 2 is not a generator of Z. This 2 is not a generator of Z. Okay. Here, do you have any generator? If I give you this question, if I give you addition modulo 4, what are the generators? What are the generators? What 0 will generate? Tell me. What 0 will generate? First, you tell me this point. What will be generated by 0? 0 can only generate 0. 0 cannot generate anything. 0 will only generate 0. What will be generated by 1? Generated by 1. 1 power 0 means identity element. 1 power 0 means identity element. 1 power 1 means 1. 1 power 2 means 2. 1 power 3 means 3. So this 1 is the generator. Because what is 1 power 0? That is 0, identity element. 1 power 0 is the identity element. 1 power 1 is 1. 1 power 2 is 2. And 1 power 3 is 3. So 1 is, so you can notice 1 can generate everything. If this is your G, then this is G. And what 2 can generate? Tell me. 2 power 0 is 0. 2 power 1 is 2. 2 power 3. What is 2 power 3? 2 power 3 is 2. 2 power 3 is 2. 2 power 4 is 2. 2 inverse is 2. 2 inverse is also 2. So I can say that. So only this you will get. That's it. Nothing else you will get. This is your subgroup generated by 2. What is subgroup generated by 3? That means 3 power 0, 3 power 1, 3 power 2, 3 power 3, 3 inverse. Okay, that means 3 inverse and so on. 3 inverse, 3 power minus 2, and so on. So what is 3 power 0? This is your identity element. That is your 0. 3 power 1 is 3. What is 3 power 3? 3 power 2. 3 power 2. This means this mode 4. So that will be 2. This will be 2. What is 3 power 3? What is 3 power 3? That will be 9 mode 4. And that is 1. So everything you got. Everything you got. What is 3 inverse? 3 inverse is 1. So everything you got. So actually you got G. So okay, everything you got. This is what you wanted. So finally, I can say what are the generators? The answer is 1, 3. These are the generators. Okay. So some things you can note, some simple notes you can make. The first thing, what is the subgroup generated by identity element? What is subgroup generated by identity element in any group? You take any group, then what is the subgroup generated by identity element? That means e power 0, e power 1, e power 2, e power 3, e inverse, e power minus 2, and so on. Everything is e, right? E power 0 is e power 1 is e power 2 is e power 3 is e inverse is e. So I can say what is the subgroup generated by e? That will be e itself, only e. So identity element cannot generate anything. Identity element can never generate anything. The only thing that identity element can generate is e itself only. So this is the point. Always identity element in any group, identity element can only generate identity element. The second point, can I say subgroup generated by A is same as subgroup generated by A inverse? Can I say? Can I say both are same? Can I say both are same? Just apply the definition. Apply the definition. What this means? What this means? This means all the integer power of A. Yes or no? Here what you have? Here you have A power 0, A power 1, A power 2, A power 3, A inverse you have, A power minus 2 you have. This is your subgroup generated by A. And what is subgroup generated by A inverse? What that will be? That will be, you will have identity element. This is same as identity element, right? So I can just write it identity element. So I can directly write identity element because that is your A inverse power 0. Then what I can say? A inverse, A power minus 2, A power minus 3, and so on. Its inverse. What is the inverse of A inverse? What is the inverse of A inverse? That will be A. So can you notice both are same? Yes or no? Both are same. Agree or not? So both are same. Exactly same. Both are exactly same. So these are the 2 points you can consider.